Oh, Chief Sohcahtoa, help me with my trig, hunting all the buffalo with triangles. Okay, so what we're going to be looking at today is quickly called Sohcahtoa. In long, it's called Trigonometric Functions. Now, what we're going to do is kind of look back to what you've talked about in geometry. In geometry, you could have these triangles, right? And they were like right triangles. And you could say, hey, look, if I have a side, an angle, and a side, I could like find everything out about my triangle. There were like a bunch of geometric proofs there. And if you had three sides, you could find a lot of things out about your triangles. But if you had three angles, you couldn't, right? And we know you can't with three angles because, pretend we have an equilateral triangle here. We know each of the angles is 60 degrees. Oops. That doesn't exactly tell you what the lengths of the side are because I could just have a larger equilateral triangle of sides 60 degrees. So angle, angle, angle doesn't really give us anything. Now, we always needed three things when we were doing those geometric proofs, but what if we only had two? Could you still do it? And these geometric proofs were nice because they didn't necessarily have to be right triangles, but if we do have these special right triangles here, could we work things out? Could we find some of our values here? And it turns out we can using Sohcahtoa. Now, Sohcahtoa, or these trig functions, stands for the following. And there's a few ways of writing it out. I like to write it out as Sohcahtoa. And if you don't like to write it out that way, maybe you'll like to write it out as that's an H, Toa. You need to write this down right now on a sheet of paper, okay? Pause this video, write this down right now, because Sohcahtoa or Sohcahtoa will save your life and a million headaches moving forward when we continue to talk about vectors. You need to write this down. Why haven't you done that yet? Write it down, Sohcahtoa, Sohcahtoa, Sohcahtoa. It's super important, okay? Now, the reason why it is important is if we have a triangle, what Sohcahtoa stands for is sine, cosine, and tangent. And these are trig functions applying to these right triangles here. And essentially, what each one refers to is looking at certain properties of your triangle based off of what you have. And we could get into unit circle arguments for this. We'll do that in a slightly later video or later in this one if we've got some time for it. But essentially, if we just want to figure out what the sine of an angle is speaking about, we can take a look and say sine, if we look at Sohcahtoa, sine is the opposite over the hypotenuse, okay? That is the so in Sohcahtoa. It's an opposite over hypotenuse. So what we'll do is this. We first need to designate an angle in which we want to compare things from. So let's look at angle A. Okay, this is angle A right here. We want to label the sides in relation to this angle A, and we're going to label them opposite, adjacent, and hypotenuse. Now, we already know that the longest side of a triangle, or the side that is across from the 90 degrees, is the hypotenuse, so that one's good. What we need is which side is opposite of side A. Well, to do that, we literally just kind of trace through angle A, and we get the opposite side here. So there's our opposite. This leads our last side to be the one that is adjacent to A right here. Yes, I understand the hypotenuse is also adjacent, but it's already the hypotenuse. It can't be two things, okay? So we've got an opposite, adjacent, and a hypotenuse. And these values are 5, 12, and 13 respectively. Now, if we want the sine of angle A here, well, the sine of angle A is the opposite over the hypotenuse, 5 over 13. And that's what the so in Sohcahtoa tells us. It tells us that for sine, sine of A, sine of the angle, equals this value of the opposite over the hypotenuse. Okay? If we do this for the second triangle here and we look at angle B, well, we need to relabel thing in respect to angle B. So our opposite, adjacent, and hypotenuse. Well, the longest side's the hypotenuse. The opposite side from the angle is the opposite. So we cut through. That's the opposite. and this is the adjacent side. Notice that our opposite and adjacent have switched from our last example. In our last example, the 12 was the adjacent and the 5 was the opposite. Now, the 12 is the opposite, the 5 is the adjacent. Okay? But when we do the cosine, and we use the Sohcahtoa term, cosine is ka, or ka, if you like to write it A over H. It's the adjacent over the hypotenuse. So the cosine of B is equal to 5 over 13 again. Okay? And there is a reason why that is true in this case. Even though sine and cosine are different functions, we're looking at different angles. Last time we were looking at A, and this time we're looking at B. Okay, so they will give us the same value. Why don't you try this with tangent, using what we know in the examples from before. So tangent is toa, or toa. So try to work that out. Try looking at this angle here, angle A, and seeing if you could write out what the value of tangent would be if you ran this. So pause this video, try it out. Boop, boop, boop. Why haven't you paused yet? Boop, boop, boop. Why haven't you paused yet? Oh, you just unpaused. Cool. So let's take a look at this. We still have our hypotenuse here. If we go through the angle, this is our opposite side, the 5, and that means the 12 is the adjacent. And then if we look at tangent, it's an opposite over adjacent, so it's going to be 5 over 12. Okay? So it's kind of a neat thing we get right there. So this is just kind of designating what sine, cosine, and tangent are using Sohcahtoa. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. What we're going to look at in our next little video is we're going to look at how we can actually use our calculator to kind of start crunching numbers for these sine, cosines, and tangents, and figuring out how we can find some of these unknown values moving through it. But until then, adios, and take it easy.